Welcome to Study Loop.
This is the answer to Chapter 17, problem number 57 from the Smith Organic Chemistry textbook. This problem says thymol is the major component of the oil of thyme. Thymol shows IR absorptions, and then we're given some peaks, and we're given an NMR spectrum as well. Okay, and so given this spectral information, we're asked to propose a possible structure for thymol. Okay, so I'm going to start with an HDI. As always, when we're given a formula and asked to find a structure, so it's going to be 2 times the number of carbons, which is 10, plus 2, minus the number of hydrogens, which is 14. All of that is over 2. So 8 over 2 is 4. So we probably have an aromatic ring here. Okay, and so let's look at the IR data. So our first IR peak, 3,500 to 3,200, that is indicative of an alcohol. 3,150 to 2,850 is going to be our CsP2 and CsP3 hydrogen bonds. And then our last two signals at 1621 and 1585 are going to be indicative of a benzene ring. So maybe instead of aromatic, I'll say benzene. Okay. And so next, if we look at the proton NMR, so 1.2 ppm doublet with an integration of 6 is probably going to be 2 methyl groups. The next signal at 2.3 ppm singlet with an integration of 3 is going to be 1 methyl group that's different than the first two. 3.2 ppm septet with an integration of 1. So if we look at signals 1 and 3 here, they're splitting each other. And so that tells me that we have an isopropyl group. Okay. And so we can start putting this all together. So we have an aromatic ring. Actually, let's just stop there for right now. So this fourth signal is going to be our hydrogen on the alcohol. And then our final signal here is our aromatic protons. So these would be the aromatics. And so there's 3 of them. So this is going to be a tri-substituted benzene ring. Okay. And so if we look at the splitting pattern of this, I just called it a multiplet, but we can actually look at the way that it's splitting. And so it's 1 singlet and 2 doublets. And so we're going to have this sort of substitution pattern where we can, say X, Y, and Z. And so we can't say for sure which substituent is where in this molecule, but it's going to be a methyl group, an isopropyl group, and an alcohol. And so, oops, that's not good. And so actually, if you use the magic of Google, you can pretty easily find that. So it's actually the methyl group that's here. The alcohol is here. And the isopropyl group is right here. But again, there's no way to make those definitive assignments based just on the information that we've been given here. We can say that it's tri-substituted, and we can say what the substitution pattern is and what the substituents are, but we can't put it all together based just on the information that we have here. But that's the answer to Chapter 17, problem number 57.